Welcome back. In this video, we are going to solve problem 10-76 that is taken from chapter number 10, Strain Transformation, and book name is Mechanics of Material by R.C. Hibbeler, 9th edition. And the topic that we are covering is theories of failure. So statement is the component of plane stress at a critical point on A36 steel shell are shown. Determine if failure yielding has occurred on the basis of maximum distortion energy theory. So you can see this is plane state of stress that is given over here. In x direction the stress is 70 megapascal. In y direction the stress is 60 megapascal and that is compressive, and the shear stress is 40 megapascal. So what if I take this axis is x-axis and along vertical we have y-axis. So from this state of stress we can write sigma x is 70 megapascal, sigma y which is given as minus 60 megapascal, and this tau of xy is equal to 40 megapascal. Why it is positive? Because you can see it is acting on x plane clear and the shear stress is in positive y direction, that is why it is positive. So we have this for state of condition. So from this I will write, from this we will find sigma 1 and sigma 2. What are these? These are known as principal stresses, and principal stresses are maximum stresses that are acting on the element. And for finding this principal stresses we have this formula which is equal to sigma average plus minus r, or you can also write it as sigma average is sigma x plus sigma y divided by 2 plus minus under the root r is equal to sigma x minus sigma y divided by 2 whole square plus tau of xy whole square. Now we will put the values over here. Sigma x is 70 plus minus 60 divided by 2 plus minus under the root 70 minus 60 divided by 2 whole square plus tau of xy is 40 square. Okay. So we can write sigma 1 comma 2 is equal to, I have calculator, so 70 minus 60 divided by 2 is equal to 70 minus 60 is 10. So 10 divided by 2 is 5. So this will be 5 plus minus the second term which is under the square root. So 70 plus 60 divided by 2, 65 square plus 40 square. And if we take the under root of this answer, so it is 76.321 and the unit will be in megapascal. Okay. Now what if I want to find sigma 1? So sigma 1 will be equal to 5 plus 76.32 and that will be equal to 76.32 plus 5 is 81.32 megapascal. So I can write sigma 1 is 81.32 megapascal. Now we'll find this sigma 2 and we know that sigma 2 will be equal to this 5 minus 76.321, and when you calculate 5 minus 76.321 that is equal to minus 71.32 megapascal. Okay, so again sigma 2 is minus 71.32 megapascal. Now you have this both sigma 1 and sigma 2. So what we are going to do is that for maximum we have to check that whether maximum, according to maximum distortion energy, it will yield or not. So for maximum distortion energy theory, if your sigma 1 square plus sigma 2 square minus sigma 1 into sigma 2, that is less than sigma yield square, so it will not yield. Under this condition it will not yield. Okay, so we will put the value. Sigma 1 is 81.32 whole square plus sigma 2 is minus 71.32 whole square minus sigma 1 is 81.32 and sigma 2 is minus 71.32, and it should be less than sigma yield square. Okay, so what we are going to do is that I will move this calculator toward this. So here you can see I have 81.32 square plus this minus 71.32 whole square minus 81.32 multiplied by minus 71.32, and we will close the bracket. So it will be equal to 17 I will round it off 17500 megapascal, and that should be less than sigma yield square. Okay, now we have been given that this material is A36 steel. So for A36, now for A36 steel we will find sigma y from average mechanical property table that is given at the end of this book. So let's move and find this sigma y. So I will go to the book. Okay, I don't have at this stage, so I will open this book, and here you can see you have this in front of you, that this is A36, so it's already highlighted. I did it for the previous problem. So 250 megapascal, the unit will be 250 megapascal. So again we will move towards sigma is 250 megapascal. And from this, if I want to find sigma square, sigma y square, so what I will do is that 250 square will give you 62500. Okay, and this will be here. I have to remove this unit because it will be the square. Okay, now you can see that if you put the sigma y value from this, if you want to do it, so 77500, you can see that is less than 62500. so this equation which is holding correct, so it means that I will write the conclusion. So based on this results, the steel shell does not yield according to maximum distortion energy theory. Or it is also known as von Mises theory or von Mises criteria. So this was all about this problem 10-76. We can compare it with our previous problem that we did the same thing for maximum shear stress theory. I hope you have enjoyed both these videos, and those who are new to my channel, then I will request them to subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you so much for your kind support.